Now, let's look at some calculation detail. We're going to need to use this information for our hypothesis testing, step 4. Okay? Now let's begin with some basic summary of statistics. First one, the first group has a sample mean equal to 8.45. That means for the 5 couple we selected for their first marriage, the average duration of these 5 couples, their marriage lasts for what? 8.45 years. For 5 couple we correct in our second group, their second marriage lasts for what? 5.5 years. For the third group of 5 couples, okay, we have a sample mean of 3.10. As you can see, first group sample mean is 8.45, second group is 5.50, third group is 3.10. You can see the number is what? Smaller and smaller, right? That means first marriage lasts longer and the third marriage lasts very short, okay? So, is the number significant enough for us to say first marriage lasts longer? All the difference among these 3 numbers can be explained by sampling error, okay? You happen to select a 3 group of couples. They shows what? They shows their average duration become what? Marriage duration give you some idea, look like they become what? Shorter and shorter, okay? Is this real? Or because what? It's sampling error, okay? Or you can explain by what? Chance error, okay? Now, and for the first group of couples, we find the standard deviation, the sample standard deviation, the sample what? Sample variance, sorry. The sample variance is 1.075, and second group is 2.2, and third group, the sample variance is about 1.018, okay? Now, if we use X bar, X1 bar, X2 bar, X3 bar, we can find what? The grand mean, or you say the overall mean of these 3 group of couples. Their average duration of their marriage is what? 5.68 years, okay? Now, for the mean square of groups, MSG, M means M, S means what? Square, G means group, okay? Now, how can we find the mean square for groups, MSG? Okay, for mean square for groups, okay, for mean square for groups, for mean square for groups, MSG, is sample size 1, here is 5, times what? The first sample mean, first group sample mean, minus the overall mean. We just find the overall mean is 5.68. This is the mean for 3 groups. Square plus N2, the sample size for second group, times what? The group mean of the second group minus the overall mean square, plus the sample size of the third group, times what? The third group sample mean minus X bar, the overall mean square. And then divided by I minus 1. In this case, we have 3 populations, 3 groups. 3 minus 1 is divided by 2, okay? And then we plug in the number we just obtained. Okay, what do we find? We find MSG. The mean square for groups is 35.9. and the mean square for errors, MSE. How we find MSE? Okay, this is another formula. Now, the mean square for ML, the mean square for L, MSE, is found by the formula. The first group size minus 1 times sample variance of the first group plus the sample size of second group minus 1 times the sample variance of second group plus the sample size of the third group minus 1 times the sample variance of the third group, and divided by total sample size minus I. This is not 1, this is I. So in our case, we have 15 observations. 15 observations. Each group we have 5 observations, and we have 3 different groups. So 3 times 5 is 15. Minus I, 3 different groups. So it's 15 minus 3. Okay? Then we plug in the numbers respectively, and we find the MSE is 1.4375. Okay? Next, let's look at ANOVA4 statistic. F is formed by variation among the sample mean divided by variation among the individual in the sample mean. And this is very easy. It's MSG, mean square for groups, divided by MSE, mean square for error. Okay? And we're going to reject H naught if F statistic is too big. Okay? If F statistic is too big. Now let's quickly look at why this decision is made like this. Okay? Let's look at what's MSG. What's MSG? A quick intuition can be formed. For detailed information, you're going to learn in more advanced statistics course. For this course, I just give you some intuition. Why decision is made like this way? Let's go back to see how we define MSG and MSE. And also how we define what? How we define X1 bar, X2 bar, and X3 bar. Okay, let's see. Under H naught is true, if the first group, second group, third group of people don't make a big difference, that means when X1 bar, X2 bar, X3 bar, they are quite close to each other. Therefore, they are all close to what? To close to X bar. This number, the difference between first group mean minus the overall mean should be small. Same thing, this is also small. This is what? X bar 3 minus X bar should also be small. Therefore, MSG should be what? Should be small. Okay? MSG should be small. So, let me write this down. The intuition, this is not a rigorous mathematical argument, okay? Intuitively, under H naught is true. We expect that X1 bar should very close to X2 bar, should very close to what? X3 bar. And they should also very close to what? X bar. Therefore, x1 bar minus x bar should be very close to x2 bar minus x bar. Should also very close to x3 bar minus what? X bar. They should all very close to 0. Okay, they should very close to 0. And what does that mean? That means they are squares. Okay, they are squares. Should also very close to what? 0. Same thing for what? x2 bar minus x bar square. Should also very close to 0. And x3 bar minus x bar square should also very close to 0. Therefore, combined with this intuition, you can imagine that MSG should be what? Mean square for group should be what? Should be small. If you add a bunch of small number, MSG should be what? Should be small. And that is why we say when this ratio MSG over MSE is very big, it support what? This is evidence more like H naught is what? Is false. HA is true. So under H naught is true, you expect to see MSG should be what? Should be small. If you see this ratio, well, MSG is too big, therefore the ratio is too big, then if you see a big F value, this kind of evidence support what? HA is true. So that's why we should have H naught rejected. This is just intuition. It's not a formal rigorous what? Argument, okay?